Welcome. Today we are focusing on the most fundamental chapters in physical geography, geomorphic processes. This topic is absolutely vital for your EMRS, NVS and KVS exams. In NVS, there will be around 15 questions expected for 4 marks each. First question, distinguish clearly between endogenetic and exogenetic geomorphic processes. Endogenetic process, the builders. Its origin is from within the earth, driven by internal heat. They are constructive forces that uplift, push and fold the crust. Result of the endogenetic process, they create high relief features like mountains and plateaus. For example, volcanism and diastrophism. Next is exogenetic processes, the destroyers. They operate on the earth's surface, driven by sun's energy and gravity. They are destructive forces that break down and flatten the land denudation. They reduce the relief level of the surface. Examples of exogenetic processes are weathering and erosion by water and wind. Next question, what is diastrophism? Explain the process of orogeny and epirogeny. Diastrophism, it is the slow internal or endogenetic force that causes large scale deformation, upliftment or subsidence of the earth crust. Next is orogeny or mountain building. It involves intense folding and faulting along linear belts. It creates high relief features like fold mountains, for example, formation of Himalayas. Next is epirogeny or continent building. It is gentle, widespread, upward or downward wrapping of continental masses. It affects plateaus and large continental plains. Question number 3. Explain the mechanism of volcanism and differentiate between shield and composite volcanoes. Magma is formed deep inside. In case of volcanism, it rises due to buoyancy through vents and erupts onto the surface as lava, ash and gases. On the other hand, shield volcano is a low viscosity runny basalt lava. It is gentle and non-explosive. It is broad base with gentle slopes like a shield. For example, Mauna Loa in Hawaii. On the other hand, composite volcano is high viscosity lava and ash, highly explosive and violent, and the shape of composite volcanoes are steep sided, symmetrical cone shape, for example, Mount Fuji in Japan. Question number 4. Explain the significance of weathering in the formation of soils and other surface processes. Weathering is the first step to creating soil. It breaks hard rock into loose material or regolith, which is the basic ingredient for all fertile soil. Weathering helps concentrate valuable ores like bauxites by washing away unwanted soluble materials. Weathering weakens the rocks, making it prone to gravity, which often leads to landslides. Weathering provides the loose material that can be easily picked up and carried away by agents of erosion. Question number 5. Describe the main types of physical weathering with suitable examples. Physical weathering breaks rocks mechanically without changing their chemistry. First is exfoliation. In that case, rock expands due to pressure release when overlaying material is eroded. As a result, curved sheets of rock peel off. For example, rounded granite domes. Next is frost wedging. Water freezes in cracks, expands by 9% and exerts massive pressure and which shatters the rock. Example, breaking of rocks in cold mountain areas. Next is salt weathering. Salt crystallizes and expands in rock pores as water evaporates. As a result, rock crumbles or pitting is happening. For example, crumbling of sandstones in coastal areas. Question number 6. How does chemical weathering differ from physical weathering? Explain the process of carbonation. Physical weathering breaks the rock in mechanical way without changing the chemical decomposition. On the other hand, chemical weathering changes rock's minerals. Carbonation. Next is carbonation process. Rainwater plus carbon dioxide forms carbonic acid or H2CO3. This acid dissolves rocks rich in limestones or calcium carbonate. As a result, it creates soluble compounds that are washed away. For example, formation of karst caves. Question number 7. Explain the role of biological activity in the overall process of weathering. First is root wedging. Plant roots grow in cracks and expand, acting as a wedge to break the rock apart. For example, a tree root splitting a large boulder. Next is acid production. Organisms like lichens and decaying matter release organic acids that dissolve rock minerals. Burrowing animals like earthworms mix the soil, bringing new material to the surface for faster weathering. Question number 8. What is exfoliation? Briefly explain the process and the type of rock structure involved. Exfoliation is the peeling off of thick carved layers of rocks, making the rock appear rounded like an onion. It occurs in massive, uniform rocks like granite when pressure is released due to the erosion of the overlaying rock. The rock expands and forms surface parallel fractures that peel away. It is common in large, uniform, intrusive igneous rocks like granite. Question number 9. What is mast bursting? Give 2 examples of rapid and 2 of slow mass movement. Mass wasting is the downhill movement of rock, soil or debris under the direct pull of gravity alone. Sudden movement, example of sudden movement is rockfall. It is free falling of rock blocks from a steep cliff. Next is landslide or slump. Rapid sliding of a definite mass of material. And example of slow movements are soil creep. It is very slow, continuous movements of surface soil. Example, tilted fence post. Next slow movement is solifluction. It is the slow flow of water saturated soil over frozen ground. Question number 10. Explain the difference between erosion and deposition, highlighting their roles in landform development. First is action. Erosion is the removal, transportation and wearing away. On the other hand, deposition is laying down of transported sediment. Erosion requires high energy like first river flow. On the other hand, deposition occurs when agent loses energy like slow flow. Erosion is destructive. It cuts the land. Deposition is constructive. It builds new lands. Example of erosion erosion forms V-shaped valleys and deposition forms deltas and alluvial plains. Question number 11. Explain the concept of denudation and its three main components. Denudation is the collective term for all external processes that cause the wearing away and leveling of the earth's surface relief. Components of denudation are weathering, it is breakdown of rock, it is a preparation process. Next is mass wasting, that is movement or shift by gravity. And next is erosion and transportation. Erosion is the removal and carrying away by moving agents. Erosion and transportation are the final removal. Question number 12. Describe the process of soil formation and its importance to the ecosystem. The soil forming process is called pedogenesis. The first is weathering. It breaks bedrock into fine mineral or regolith. Next process is humification. Dead organic matter forms humus or a fertile material. Next process is horizon development. In that case, water washes minerals down or leaching or alluviation and creating a distinct layer or soil horizons like A horizon, B horizon, C horizon. Next, the process, importance of the soil forming process. Soil is very crucial because it provides water, nutrients and physical support for all plant life, sustaining the entire terrestrial ecosystem. Question number 13. Discuss the influence of parent material and time as factors controlling soil formation. First is parent material. It is the rock. It determines the soil's initial chemical composition and texture. that is sandy or clayey, etc. For example, soil from basalt leads to the fertile black soil or regur. Next is time or duration. It is the time taken for the soil to fully develop. For example, old or mature soils have clear horizons, while young soils still look like the original rock. Question number 14. How does climate influences the type and rate of weathering processes? Climate, that is heat and water, is the main control. In hot and humid climates or in tropics, chemical weathering is dominant. High heat and abundant water maximize chemical decomposition. And in cold climates like alpine and polar region, physical weathering is dominant. Freeze-thaw cycles or frost wedging are highly effective. In dry climates or deserts, physical weathering is dominant. Lack of water limits chemical action, but large temperature range or large temperature swings cause mechanical stress. Question number 15, it is the final question. How does chemical weathering differ from physical weathering? Physical weathering is mechanical disintegration or breaking the rocks, and chemical weathering, chemical reaction or decomposition happens. In physical weathering, mineral composition is same, but in chemical weathering, minerals change into new substances. Physical weathering found in cold and dry climates, and chemical weathering found in hot and humid climates. Examples of physical weathering are frost wedging or exfoliation, and examples of chemical weathering are carbonation and oxidation. We have covered the 15 most important questions on geomorphic processes. Remember that the Earth's surface is always in a state of dynamic change. Endogenetic forces provide the materials and elevation, and exogenetic forces tirelessly work to wear them down. Mastering the concepts of weathering, mass bursting, erosion and soil formation will ensure you score high on this crucial chapter in your upcoming exams. Good luck with your preparations.